ball of mass 150 grams is hit horizontally from the top of a 40-metre high cliff with a speed of 25 metres per second. Using g equals 9.8 and ignoring air resistance, calculate the following values. First of all, we are calculating the time that the ball takes to land. All right, so first step, draw a diagram. If our ball is hit horizontally, it's going to move something like that. Our initial conditions that we know, let's put in the things that we know. So its initial velocity is, what is it, 25 meters per second? In the horizontal direction. What's its initial velocity vertically? 0. It's being hit exactly horizontally, so it has no vertical velocity. All right, we know that the height of the cliff is 40 meters. Which of our SUVAT letters is that going to be? S, distance travelled. Our ball is going to go from the top of the cliff to the bottom, so S is going to be 40. So let's put in the SUVAT letters that we know. S is 40. Then we have U is 25. We have A. Now I'm doing a bit of a naughty thing here. Our U and the A are in different directions. I shouldn't put those both together in the same equation. So if A is 9.8, we're talking about our vertical. I should probably put U equals 0, because our vertical velocity is 0. Okay, it's not moving downwards at all initially, so its vertical velocity is going to be 0 initially. And so this is important. You can't look at the vertical and horizontal components at the same time. You have to look at one after the other. You have to look at them separately. So if we want to know the time the ball takes to land, remember that the horizontal component has no effect on the vertical component. So it doesn't matter whether we hit the ball horizontally or drop it. It will still take the same amount of time to hit the ground. So let's assume that we are just dropping it then. Okay, and then we know our S value is 40 because it's going to drop 40 meters. We know its initial velocity is 0 because it's vertically, it has no velocity, and the acceleration is 9.8. So I am considering downwards to be the positive direction here, right? Because it's traveling 40 meters downwards, so it's positive 40 meters, and the acceleration is 9.8 meters per second squared downwards. Again, that's positive. Okay? If we considered up to be positive, both of those would be negative, but you should still get the same answer as long as you're careful. All right, so what do we need to find out? We need T. There we go. That's a bad looking T. So when you're doing a SUVAT equation, this is why you write down what you know and what you want to know. If we know these three things and we want to know T, then we can just find a SUVAT equation that has all of those things in it. Okay? And if you have a look at the booklet I gave you out earlier, you'll see that that is going to be the one we're going to use. Okay? Everything in this equation is relevant to what we're doing. We know S, we know U, we know A, and we're trying to find T. That's our equation. So let's simplify. S equals UT. If U is 0, UT is 0. So we can leave that term out. So S is equal to 1/2 AT squared. Now we need to rearrange this to make T the subject. So we get T is equal to 2S on A square root. Now I'm doing this in one step. You can do more steps to rearrange that equation if you like, but I'm just doing it quickly. But yeah, it'd just be a matter of multiplying both sides by, dividing both sides by 1/2 or multiplying by 2, dividing both sides by A, and then square rooting both sides.
2.86.
I like that. So if we put our values in, T equals 2 times distance, 40 over 9.8 square root. Now, this is the way I want you to start setting out your equations if you haven't already, because remember I told you that last year's exam, there was a particular question where you got 1 mark for using the correct formula, that one, 1 mark for putting in your numbers correctly, and another mark for getting the right answer. So do those three things. Formula, input your numbers, and then calculate it. All right, don't skip any of those steps. And I think if you work that out, what do we get, 2.86 you said? So 2.86 seconds. So it takes our ball 2.86 seconds to hit the ground. Now let's give it the common sense test. Does that make sense? Seems about right, doesn't it? A golf ball from 40 metres, that seems about right, 2.8 seconds. If you got something here like 3.5 minutes, you know you've gone wrong somewhere. So calculate the distance that the ball travels from the base of the cliff, i.e. the range of the ball. So this is actually really easy. So we want the distance the ball travels from the base of the cliff, so we just want that distance there. That's all we need. So, are we looking at the vertical or the horizontal component now? Horizontal. We want the horizontal. So, we know the, well, what do we know? We know the horizontal velocity is what? 25. We know, well, we don't know the distance. We're trying to find that out. Do we know the time? Yeah, we do. We just figured it out. 2.86. So velocity equals distance over time, which means distance equals velocity times time. So 2.86 multiplied by 25 will give us 71 point something, I guess. $71.5 meters. So that's where there's that really useful aspect of horizontal projectile motion. The horizontal velocity doesn't change. And so you can just use velocity equals distance over time to work out the horizontal motion of it. Okay? If you know how far, or if you know the horizontal speed and you know how long it's taking, distance is real easy. Okay? There's no acceleration, so we can use that. All right, next. Calculate the velocity of the ball as it lands. This is a little trickier. Velocity, we need two things, speed and direction. So if we think about it, if we look, if we zoom in up here, then our ball is going to be traveling at an angle when it hits the ground. So we need to know, first of all, how fast it's moving and what that angle is, which isn't that tough because we know a couple of things. But what's really going to help us here is Pythagoras. So there's a right angled triangle. We want our hypotenuse. This, the side down the bottom is just our horizontal component of our velocity. Okay, 25. So if we know the horizontal component and the vertical component of our velocities, we can just work it out. Projectile. So our vertical component now, this is where we need to actually be a little bit cleverer. We don't know what our vertical component is, so we need to calculate it. So if we think about the vertical direction, let's look at the SUVAT stuff that we know. We need V. We don't have V yet. Okay, in only the vertical direction, we don't have V. Do we have U in the vertical direction? 9.8?
No.
Not for U. That's for A.
Oh, yeah.
A is 9.8. What's U in the vertical direction? Initial speed? 0. And we know time. What's time? 2.86. There we go. And so we can use the easiest of the SUVAT equations. V equals U plus AT. U is 0, so it becomes even easier. So our velocity in the vertical direction is equal to 9.8 multiplied by 2.86.
28.028.
28, let's call it 28. Meters per second. So now, look at this, we're getting much easier. Our vertical component is 28. Oh. Our horizontal component is 25. So to find the speed of our ball as it hits the ground, we just use Pythag. So 28 squared plus 25 squared. Yep, square root that.
37.54.
37.54. Sounds right. I've just messed up my calculator. I'll take your word for it. 37.54 meters per second. That's that side. So now we need the direction as well. So we can use trig for this. So let's find that angle there. That's going to help us. So let's use tan. Tan theta is equal to 25 on 28. Have I explained why I would use tan in a case like this rather than the sine or cosine when we just work that side out?
We carry the arrow.
Yeah, exactly. If I've mucked up this number here, you don't carry it through. All right? So use the values that you know are correct, or at least you're most likely to be correct. And so I get that to be 0.89. So our angle is going to be inverse tan of that. 41.8 degrees.
41.82 degrees.
Yep, something like that. So we could say, so a good way of putting this to explain this direction, if this is 41.8, then that will be, what's that, 48.2? So we could say that our projectile, as it hits, or as it lands, has a velocity of 37.54 meters per second at an angle of 48.2 degrees below the horizontal. Okay, that's not a bad way to put it. But when you need to find a velocity for a projectile, that's what you need to do. You need to keep the vertical and the horizontal components completely separate, work out one at a time, and then put them back together at the end. Once you've got the vertical and the horizontal, you can work out the overall velocity.